Thermodynamics studies the interchange of heat and work between the system and the surroundings, which occurs when the system undergoes a process. Most thermodynamic substances, such as gases and vapors, often referred as PVT substances. An ideal gas obeys the equation of states, which relates the specific volume or density, pressure, and absolute temperature with mass of molecule and gas constant R. However, the real gas does not follow the equation of state. A few modifications on the ideal gas equation of states allows its application in the properties of real gas. The state of equilibrium depends on the pressure between the water surface and steam, and the pressure where equilibrium occurs at a given temperature is called the saturated pressure. For this experiment, Marshall boiler is used to investigate the relationship between the pressure and the temperature of saturated steam in equilibrium with water at all temperature levels by relating with Clausius-Clapeyron equation and also from the steam table.
Experiment. Marshall boiler is used to investigate the relationship between the pressure and temperature of saturated steam in equilibrium with water at all temperature levels between the gauge pressure of 1 bar and 5 bars. The water inside the boiler is heated up by the electrical resistance and starts to evaporate. As more water changes phase from liquid to vapor, more vapor accumulates inside the boiler vessels and increase the pressure imposed on the water surface. This pressure build-up tends to increase the resistance faced by liquid molecules as they change into vapor, consequently increasing the saturation pressure of the remaining liquid. For a pure substance existing as a mixture of two phases, the Clapeyron relationship relates the pressure, heats, and expansion during a change of phase, provided that the two phases are in equilibrium. So the working equation for this experiment is based on the Clapeyron equation, which is delta T over delta P saturated is equal to T times in bracket Vg minus Vf over Hg minus Hf, also can be equal to T times Vfg over Hfg, in which Vf is the specific volume of saturated liquid, Vg is equal to specific volume of saturated vapor, Hf is the enthalpy of saturated liquid, Hg is the enthalpy of saturated vapor, Hfg is the latent heat of vaporization, while T is absolute temperature and P is equal to absolute pressure.
First step is the boiler for heating and cooling process is being set up. Next, once the air has been fully purged from the boiler, start to take the readings of temperature and relative pressure at the intervals of 1 bar until relative pressure that we have been decided, which is 5 bar. After that, repeat the steps for cooling process, and lastly, process the results and analyze them to get the data.
As we can see, there's a graph of temperature against pressure, and this is a table of the graphs. Next, we have a graph of log P against log P and graph of 1 over T against ln P. Okay, for the correlation of the three graphs is to show that the temperature is increases with pressure. Okay, when we transfer in straight line function, we can set that the temperature and pressure is directly proportional when we plot it together, and as we can see, the 1 over T against ln P graph, the is inversely proportional, and that we can assume that the temperature is increases with pressure. Okay, this is the graph of temperature average against pressure bar. Okay. Based on the graph, relation between temperature average and pressure is directly proportional. Okay. There's some errors during the experiment that make them deviate from the actual value. So the possible error is because of the room temperature and pressure, and then the reading of the data when we looking at the thermometer. Okay, and as the air should be expelled first because it is to correct the equilibrium measurement between the steam and the boiling water, and it also can malfunction the boiler and we can get the wrong data. And then for the water properties, it is heated to boiling point to increases the temperature and pressure. For steam, it increases the internal pressure and force. Okay, the common use of this experiment is Rankine cycle, where they use it to obtain a high efficiency of the system. And as for Rankine cycle, we have a 4 component, which is boiler, condenser, pump and turbine. And as for the safety valve and blow valve in this experiment, it is used as a fail-safe system that is commonly used in plant. Okay. And then the blow-off valve is to make sure there is no steam in the boiler.
Master boiler is used to study the relationship between pressure and temperature for water. When the water reaches the boiling point, the valve needs to be closed to increase the pressure. The valve also needs to be closed as it reaches the boiling point, so water will constantly in saturated liquid phase. From this experiment, we learned that pressure and temperature is directly proportional. For the recommendation, in order to get accurate readings, the steps need to be repeated at least 2 or 3 times to get the average readings, which is better experimental result. We also need to take the data professionally and avoid silly mistakes and simple errors such as the position of eye towards the scale. We also need to use the equipment properly following the instruction and be careful with hot steam as it can bring injuries.